Hello, this is video number 2. In the last video, we established the 4 axioms needed to derive Maxwell's equations in both Gauss and SI units. And we had, for the Gauss units, these expressions, and for the SI units, these expressions. In heaviside Lorentz systems is these expressions without the term 1 over 4 pi. The units of left-hand side of the 4 axioms are the following. The electrical energy density is in joule over cubic meter or Newton over meter square equals D over centimeter square. The same is applied for the magnetic energy, and the unit is in Newton over meter square or D over centimeter square. The electrical power losses are in joule over cubic meter and second or watt over cubic meter and equals Newton over meter squared and second equals D over centimeter square and second. The power flux is in joule over meter square and second or watt over meter square equals Newton over meter and second or D in centimeter and second. In summary, the electrical and magnetic energy are expressed in Newton over meter square or D over centimeter square, and the power flux in Newton over meter square and second or D over centimeter square and second. The flux is in Newton over meter and second or D centimeter and second. A short reminder of epsilon and mu. The electric displacement vector D is defined as the product of epsilon times capital E, where epsilon is the permittivity or electrical constant, as we have said in video number 1, equals the product of epsilon naught times epsilon sub r, where epsilon naught is the permittivity of free space and epsilon r the relativity permittivity, which is equal to 1 plus C sub E, and C sub E is the electric susceptibility. The magnetic induction vector B is defined as the product of mu times capital H, where mu is the product of mu naught times mu r, where mu is the permeability and mu naught is the permeability of free space. Mu r is the relativity permeability equals 1 plus C sub m, where C sub m is the magnetic susceptibility. Now, in Gauss unit system, we define epsilon equals mu equals 1, and from axiom number 1, we can deduce the unit of the electric strength, which is analog to W electrical. That means is equal to D square over centimeter. The same is for the magnetic strength, which is called 1 ester equals to square root of D over centimeter. From axiom number 3, we have sigma equals to capital E square over P thermal, and if we put the units, we have sigma equals 1 over second. From axiom number 4, we have the unit of C, which is expressed in centimeter over second. That means that C is a velocity, and we put C equals to 3 times 10 to the 10th centimeter per second, which is the velocity of light, the speed of light. In MSI units, we define C equals 1 and E equals Newton over Coulomb. As we have said in video number 1, Capital E and capital H do not represent forces in the framework of Newtonian mechanics, so their units are not expressed in Newton. The existence of the electrical strength capital E is due to the presence of an agent or carrier of the field, which we call it charge, and is represented by the letter Q, and its unit is Coulomb, or CB in short notation. The strength of the electrical field capital E is the force, Newton, per unit charge, Coulomb. So its unit is Newton over Coulomb, and the force is F equals Q times E. Therefore, the unit of E is Newton over Coulomb equals joules over meter, and Coulomb equals volt over meter, where we define a new unit, volt equals joule over Coulomb, and the unit of E becomes volt over meter. From axiom number 4, we can deduce the units of magnetic strength. Newton over meter a second is the unit of flux, of the power flux, and here is the unit of electric strength, Newton over Coulomb, times the unknown unit of H. So the unit of H becomes, if we put the expressions, equals Coulomb over meter and second equals ampere over meter. And by definition, ampere is Coulomb over second, which means the strength of magnetism capital H is produced by the moving charge or the current, which is the charges per second. 1 Ørsted is equal to din, square root of din over centimeter equals 1000 over 4 pi ampere over meter, which is the relation between Gauss and SI system. Notice that the electrical strength capital E is produced by static charges and the strength H by moving charges. And for the total force, we write F equals Q times E plus cross product of V and B, which means magnetism is a relativistic phenomenon because of the presence of velocity. We have to specify an inertial frame of reference. In summary, the units of electric strength E is volt over meter, which is the force per unit charge, and for the magnetism B is ampere over meter, which is the force per unit current. Now we define the units. We can now define the units of epsilon, mu, and sigma from the other three axioms. From axiom number 1, we have the unit of epsilon equals W electrical over E square equals, if we put the units, in Coulomb over volt and meter. We define 1 farad equals Coulomb over volt is the unit of epsilon, farad over meter. And we can, by definition, by experimental, we have the epsilon naught equals to 8.85 times 10 to the minus 12 farad over meter. From axiom number 2, we have the unit of mu equals, if we put the units equals to Newton over ampere square, where mu finally becomes ohm times second over meter, and define 1 Henry equals ohms times second, and mu, the units of mu, is 1 Henry over meter. From axiom number 3, you have the unit of sigma, which is equal to finally to Coulomb square over volt Q Coulomb meter and second, and we define 1 Siemens equals ampere over meter, and the units of sigma is Siemens over meter. And in summary of the units epsilon and mu and sigma, we have epsilon, the electric constant, equals farad over meter, and 1 farad is equal to coulomb over meter. Mu, the permeability, is 1 Henry over meter, and 1 Henry is Ohm times second. Sigma, the electric conductivity, is Siemens over meter, and 1 Siemens is ampere over volt. The units of d, b, and the flux phi equals b times s, the dot product, is for the unit of electric displacement vector d equals coulomb over meter square, and for the magnetic induction vector b equals volt times s over meter square, and we define 1 Tesla equals volt second over meter square. And 1 Tesla is equal to 10 to the 4th Gauss, where Gauss is the units of Gauss system is 1/10 Din over ampere and centimeter. Now for the magnetic flux, we have 1 Weber equals volt times second, and 1 Weber is 10 to the 8th Maxwell, and 1 Tesla is Weber over meter square. In summary, for the units of E, D, H, and V, we have for the electric, the strength is the strength E is equal to volt over meter, and for the displacement is coulomb over meter square. In magnetism, the magnetic strength H is ampere over meter, and for the induction is volt second over meter square, where we define 1 Tesla equals to volt second over meter square, and 1 Tesla is 10 to the 8th Gauss. As for the flux, we have the Weber, which is volt times second, and 1 Weber is 10 to the 8th Maxwell, and 1 Tesla is Weber over meter square. Finally, we have this table of all the units we have defined so far in this video. Thank you very much.